Hi students. So in this video we try to understand the thin film deposition in VLSI process. So in the previous video we have seen different masks, and we said that okay, in each of the masks we want to have N well and P diffusion, N diffusion, metal deposition, polysilicon deposition, thin oxide deposition, all those things. So here we are going slightly deeper into the understanding of thin film deposition. So let us try to understand what is the int- uh, different features of thin film deposition. So I'm just running through the textbook, which is Silicon VLSI Technology by Plummer, and this has been shared with you people. Now we will see, this is in chapter 9. So CMOS process flow has got many layer deposition. So we begin with different issues that are there in thin film deposition. These issues are important when evaluating the deposited films and choosing the deposition methods. The first issue is quality of the deposited layer. So now when we say deposition, now we have to see what is the quality of the deposited film. So what is this actual quality? So by quality we mean the composition, contamination levels, and defect density and mechanical and electrical properties. So when we say deposition, it involves the quality of that deposited thin film. So the quality means, so what is the composition of that, what is the contamination level of that particular deposited thin film, what are the defects that are there in that, and what is its mechanical and electrical property of that material. So when we say composition of the films, so it just depends on, it may of course may vary depending upon the deposition conditions, and it is usually important to achieve specific compositions. So you are looking for different composition. So usually we know that whenever you are depositing a particular thin film, the thin film may not be of a single material. It can be composition of various or one or two materials. So maybe if we can take this titanium nitride film, which will have a certain composition of titanium and nitrogen. So this is what it can be either titanium rich or it can be nitrogen rich. So we need to have a proper composition. It can be a thin film of aluminum and copper composition. You can have a percentage of aluminum and copper keep on changing. So this is what is one of the property. The composition of the film is need to be very carefully understood, and generally there need to be a low level of contamination. So contamination should be as less as possible, such as unwanted metal, water, oxygen, and halogens should not be there in that thin film that is deposited. There should also be a minimum number of pinholes or other structural defects to have a good thin film deposition. These often result from particle contamination on the surface and are common problem in thin film depositions. So in thin film deposition, these are a very common thing to have all these defects. So we have to ensure that these defects are minimum, and there should be a minimum stress in the films. Whenever we are depositing the film, thin film, so it should have very less stress, so that film should be mechanically stable during the subsequent process. Of course, naturally, we have seen that whenever we are doing fabrication, there are so many layers that will be uh, processed one above the other. So meaning that the process of fabrication will not complete in a single process. It will have subsequent processes. After first N well, you're going to have diffusion, and then you're going to have polysilicon, then you're going to have another diffusion. So when you are doing these n number of diffusions, suppose if the earlier deposited thin film got what decomposed, or if it is not stable, then the entire process will be a waste. Like, so that's why they should be mechanically stable during the subsequent processing. And finally, a good adhesion to the underlying film is very important, because we are placing one above the other, so it should be properly get uh, of course, adhesion means, okay, it should be properly connected to the underlying layer, so that the layers are intact and you can going to get the final structure, which is very robust one. The second issue is that the uniform thickness across the wafer. And of course, when we know that, okay, all these things will happen over the wafer at a time. As now the uniform thickness is a must. And of course, from wafer across the wafer should be same. Whenever you're doing for one wafer, the second wafer should also have similar type of thickness. It is not only across wafer, from wafers to wafers also it should have same dimensions. And as film crosses non-planar topology, and when I say non-planar topology, because on a substrate you may not have completely uniform planar structure. You may have a slight difference in height whenever you're depositing. We'll see that in the coming figure. Shows metal layer deposited over a non-planar topology, in which okay, this, let me just show you that figure. That is 9.1. So suppose if the deposited layer is something like this, you can see now it's not a planar one. You can see you have underneath, you have some of the structure. You can see you have this step. So now on this step I have to deposit the metal. So the good deposition is something like that is visible on the left hand side, that is on this figure A. Now this is step coverage of metal over a non-planar topography. So on this is a non-planar topography. You have this a change in the height here. Whenever you're depositing, this is a perfect deposition where you can see this layer thickness is uniform throughout this as well as this. But typically what happens, this is how it happens. This is figure B, shows a poor step coverage. So over here this is not having the same dimension as this. You can see now it has reduced. So this will actually increase the resistance of this metal. So here you can see this has got some thickness, and since the thickness has reduced, the resistance of this metal will going to be higher compared to this region. So that's what it says here. In right illustration, film thickness, okay, now this is the right one. So now decreases as it crosses a step, which can lead to high electrical resistance in the metal film and greater chances of mechanical cracking and failure. So because of this reduced coverage, so this may finally end up with some mechanical cracking, and it may just fail. Coverage on the sidewall of a step in topography is called as step coverage or sidewall coverage. The sidewall coverage should be a proper one. It is often defined of course, it is often defined quantitatively as the minimum thickness deposited on the side of a step divided by the thickness of the deposited on the top of the horizontal surface. So meaning, so how do we define this? Okay, a step coverage. So it is often defined uh, quantitatively as minimum thickness deposited on the side of a step divided by the thickness of the deposited on the top and top horizontal surface. So if you can see there down, so we have okay, associated a related issue, that is filling. So that is one problem, that is the step coverage. So this is one step coverage. Let us see the other problem. A related issue is that filling up the spaces between or within the topographical structure. So this includes filling the vias or contact hole with metal as illustrated in 9.2a. So let us see what is 9.2a stands for. Now you have a space here. This space need to be filled with metal. So this is a perfect filling, shows a good filling in the via. So this is a via. So you can see this is a via. Now it is get filled properly. Okay, this is shows a good metal filling of a via or a contact hole in a dielectric layer. So this is a dielectric layer, you're just filling this. This B shows a silicon dioxide dielectric film, okay, filling of the space between two metal lines. You have one metal line here, you have another metal line here. So these two metal lines are filled with this oxide. While filling this oxide, so it is poorly filled because it is leaving a void here. So there is some empty space left out. This is a air bubble left out. When you're filling, there is a metal here, there's a metal here, and you're filling those metal region using, of course you're just filling this region in between the metal using this oxide. So during that filling, this is a poor filling coverage because you are creating a via here. And the third one shows a poor filling of the bottom of the via with a barrier metal. With a barrier metal, you can see now you have a oxide here, you have an oxide here. So this entire thing, of course you're supposed to cover this. Since this width is less, whenever you're depositing something, so it is not covering. You can see this is not covered here, this is not covered here. So this is a very poor covering of the via. So why this happens is, this happens because the aspect ratio of this, because when the height is more and more, you need to have larger width so that this covers the entire dimension, this W. So that's what is, you can see here. An important parameter that can affect the filling and bottom coverage is the aspect ratio. This is what is aspect ratio, which is nothing but height of the feature divided by the width of the feature. So if this height is too much, then if this width has to be covered, then the height has to be lower. Suppose uh, for whenever this height becomes large, to have a proper coverage, you need to have this W should be more and more. This W should be more and more. So this the feature could be a metal line. For example, this is what is 9.2b. A deep narrow contact hole would have a large aspect ratio and would be harder to achieve, because when the aspect ratio is more and more, what do you mean by aspect ratio more? If the width between this, if this is the width, if that width is less compared to the height, the aspect ratio is more. You can see here, where is that? So this is here, gap between two lines. A deep narrow contact hole would have a large aspect ratio. That's what it is. A deep narrow contact hole, this is deep means this height is more, and narrow means this width is less. When height is less and width is low, you have a narrow contact hole, would have a large aspect ratio and would be harder to achieve the good bottom filling or to fill it completely. So bottom filling will become very difficult because the aspect ratio is more. So aspect ratio, if it is more, so when does the aspect ratio is more? When it is a deep filling and narrow filling. So this is narrow means width is less, the deep filling is height is more. So when the aspect ratio is more, then coverage and filling this is a typical difficulty. So we have to keep the aspect ratio not too large, so that you will end up with this problem of not filling this particular these narrow and deep fillings. You can see there are two examples that have been discussed here. Two examples of poor filling and coverage. Poor filling and coverage shown in figure 9.3 shows. Let us go to 9.3 and try to see what is that they are doing. So it has got a coverage of titanium tungsten. So this is a titanium tungsten composition, and this is one layer, aluminum is another layer, and on top of that you have again titanium tungsten. So this is a three layer metal stack. One is the composition of this titanium and tungsten, and on top of that you have aluminum. Again on top of that you have a titanium tungsten metal stack over an oxide step. So let us see how it looks there. So 9.3, this is 9.3 figure, if you can have a look at it. Of course, this shows a part of poor step coverage of so and so, and part B shows the void in oxide layer for a narrow space between the metal lines. So it is showing a void and it is showing a very poor step coverage. So we will see that in filling and depositing a very deep contact and vias conditions that would lead to good step coverage actually hinder the adequate filling and what. Okay, so what they are trying to say is, whenever you're doing a deep and narrow filling, so the aspect ratio has to be not too much. So I can just see here, this is what, can you see, this is oxide, and this is titanium tungsten, and this is aluminum, and this is again titanium tungsten. So can you see there is a step here? So this was supposed to be deposited, you can see now. So this is a poor step coverage. So because you can see this is your thickness of your what is that, tungsten and sorry, titanium and tungsten. So here this is there, and you can see this much was the deposition of aluminum, but it is aluminum is coverage, step coverage is very very poor, and you can see the step coverage of titanium and tungsten is also poor. Can you see ultimately this is a very very poor step coverage, and this is one problem of step coverage. And if you can see here, this is of course when you have this, so this is what you're trying to this is the bottom filling. The bottom filling is, this is so less, and of course you can see the thickness is less, and you have the tungsten, sorry, the aluminum is deposited this much on top here, but here it is in this region it's only this. And if you can see, of course what does this A shows is, shows a poor step coverage of titanium tungsten aluminum, again titanium cover deposited over a piece. Okay, we'll see what is a sputter deposition. And then you can see the B. So this is your B picture, shows a voids in chemical vapor deposition oxide. Okay, this is the voids. So this is the air bubbles that have been created during the deposition. So the overall thing what we are trying to see over here is, whenever you're depositing any thin film, so there are so many issues associated. So as we saw initially, the composition should be good, the contamination should be as small as possible, it should have very less mechanical stressing, it should have very good electrical properties, and its okay, addition to the subsequent layer should be very good, and it should not have any defects. And we saw whenever you have a non-planar topography, how does the coverage will going to happen. We saw the step coverage will be poor, okay, whenever you're depositing the things. And then okay, whenever you're filling something, you may not be filling it properly because the aspect ratio will be too much. So these are the issues that are there coming up whenever we are depositing the thin film on a substrate. Because now you can see, so in the while drawing the mask, so we simply said, okay, you have this, okay, 4 to 5 different masks, and do the deposition. The deposition is not very easy to make sure that the expected or the desired dimension may not be properly done if you're not taking care of the actual issues that are there during the deposition process. In the next video we'll see what is this CVD technique, and then how the actual deposition will happen on the substrate for different materials. Thank you.